cube root graphs. Cube root graphs do not have an endpoint. They go on forever in both directions. So we get arrows on both ends, and they just kind of have this swoop that happens in the middle of the graph. We are going to graph them much the same way as we did square roots. We're going to think about our shifts, and then we're going to make a chart. So how does the +2 move the graph? The left 2 and the -1? Down 1. So we're going to go to the left 2 and down 1 to make our starting point. That is not an endpoint because we don't have an endpoint this time, but that will be the center of our graph. That'll be right in the middle of that swoop that happens. Then we're going to make a chart for the stuff we haven't done yet, which is 3 cubed root of x. This time, instead of using 1, 4, and 9, those were perfect square root numbers. This time we're doing cube roots, so we want some perfect cube root numbers. 1 and 8 are good numbers. 27 is good too, but I can guarantee you I'm not counting 27 spaces to the right to make a point. So, what else? Negative 1 and negative 8. We can take cube roots of negative numbers. So negative 1 and negative 8 are also going to be included here. We'll use these 4 every time. Yep. If I take the cube root of negative 8, that's asking what do I multiply 3 times to get negative 8?
Negative 2.
Negative 2 times the 3 that's in the front gives me negative 6. Cube root of negative 1 is negative 1 times the 3 in front gives me negative 3. You could, yep. And we will always have a nice symmetry that happens. I can talk about that later. I would rather you do it in your head because we should know what perfect cube roots are. So we can talk about how to use a calculator to cheat a little later, but we need to learn our perfect cube roots. Then we're going to plot these points like we did from that new point that we plotted, pretending like that's our origin. So it's not an endpoint, it's the middle of the graph, but we're going to pretend like that's our origin. So from that point, I don't have room to go -8, so I'm not going to worry about that first point for this graph. There's just not room to do it. So I'm going to start by going back 1 and down 3. Forward 1 and up 3. And forward 8 and up 6. And connect on through. We get arrows at both ends this time. You should have 4 points in your graph. The 3 middle ones for the swoop, and then you should have one of those edge points that you can see how the curve is forming. Domain and range. So we put arrows on both ends here. So what do you think about domain?
Greater than or less than negative.
Yeah, those arrows point me along the entire x-axis, so it looks like we're going to get everything. What do you think about range? It is the same. It is forever going up and forever going downward. It's just doing it really slowly. It goes sideways a lot faster than it goes up and down, but it does keep on heading upward and downward. So our domain and range are all reals, and always will be for cube root graphs.
Also when pass.
So domain and range are all real numbers for cube root graphs. For the next one, what do we do with the -3?
+3.
Go over to +3 and the +2? Up 2. So I begin by going to the right 3 and up 2. That is the middle of our graph. Then we make a chart for the stuff we haven't used yet. -1/2 the cube root of x. In the chart, we use our 8s and 1s. What's the cube root of -8? -2 times -1/2? positive 1. Cubed root of negative 1. Negative 1 times a half. Negative half, sorry. Because that's positive a half. You will always have a nice symmetry. So if you don't like plugging in the negative numbers, just plug in the positive numbers. Plugging in 1 gives 1 times negative a half is negative a half. Plugging in the 8 gives 2 times negative a half is negative 1. So if you don't like plugging in the negatives, don't do it. Just plug in the positives, and then you'll have a nice symmetry for the other two. Then we're going to plot these. This time I have room to go back 8 and down 1. Up 1. Where's that point? And back 1, up a half. Forward 1, down a half. I don't have room to go 8 to the right, so these will be our 4 points. Once again, the multiplier in the front kind of tells us about the height of this. So that multiplier of a half, this is going to make a pretty short one for us, whereas the last one had a height of 3, so that's going to make a taller graph. The negative in the front here did also flip it upside down so that it's ending pointing downward instead of ending pointing upward. It's not as much of a concern with the cube root as the square root, though. And domain and range? All real numbers for both of them. Go ahead and try the next example. So we begin by shifting to the right one and up 1 to get the middle of our graph. Then we make a chart for y is equal to the cubed root of x. When there's no multiplier in front, it's like the multiplier is just 1. And we use the same 4 numbers we used in the previous ones, our perfect cube root numbers. Gives negative 2, negative 1, 1, and 2. I don't quite have enough room to go back 8, but I'm just going to fall off the graph a little bit so that I can go back 8 and down 2, so that I can get that 4th point out there. And then back 1 and down 1, forward 1 and up 1. And I don't have to do that other one. But as I trace out the right-hand side, I'm going to make sure that I don't cross over that next line because I know it's not going to reach that height until it gets 8 spaces out there, and I'm not making it that far. So I kind of have that as my border, that I don't want to cross up over that next line. And domain and range will be all real numbers. For cube roots, they will always be all real numbers. Not for square roots, because those have an endpoint, but cube roots will be all real numbers. The homework is from 7.5.